Okay, so let's look at the next example. Find the tangent vector, normal vector, tangent vector, and normal vector. So this one, I think this is something wrong with the question here. Find the unit tangent vector and unit normal vector for the vector value function provided, and sketch the curve, sketch the unit tangent, sketch the unit normal vector when t is equal to pi over 2. Okay. So here now we have, just like I mentioned before, now we have a 3D, 3D because we have x, we have y, we have z. But then, unfortunately, we have a different function here, so you cannot use the previous example. So you have to find out the new capital T, capital N, and evaluate them. Okay. So the f given, sin t minus 2 cos minus 2 cos t 5. Okay, so we have to differentiate 2 cos t, 2 sin t, and then 0. Then we have to find the magnitude, where we have the square root of 4 cos square t plus 4 sin square t plus 0. So it looks like we can factorize. So we have cos square t plus sin square t. And this one becomes 1, so you got 2. So that is your magnitude. And then to get t, we know that f prime t divided by its magnitude. So then we can have cos t, so the 2 gone, sin t 0. So that is our t. And now we work on n. In order to do that, you have to differentiate your t minus sin t cos t 0. Okay, and then find its magnitude. So sin square t plus cos square t, and this one from the identity of trigo, then we got 1. So then compute for n. The formula is t prime divided by its magnitude. Okay, so this one divided by 1, then we obtain that negative sin t cos t 0. Okay, so we got everything, but then you need to evaluate them. Okay, so now, so add, so at t equal to pi over 2, so your f at pi over 2, your position vector, so you replace into the equation, so you will have 2 sine pi over 2 negative 2 cos pi over 2 5. So you will get this is 1 and this is 0, so you will get 2 0 5. Okay, so now your t, unit tangent, at pi over 2. So we substitute into the t that we obtained just now. So our t is cos pi over 2 sine pi over 2 0. So we got cos pi over 2 0. This is 1. So we got 0 1 0. And then your n at pi over 2. So your n just now you obtain that negative sine pi over 2 cos of pi over 2 0. So this is 1, this is 0. So we obtain minus 1 0 0. So now it's time for us to plot. Okay, firstly you have to find out what is the curve of this, okay, which is from this equation. So to do that, so we put a parametric equation. So sorry, start with the x equal to 2 sine t, and then y equal to minus 2 cos t, and then z equal to 5. So in this case, z is fixed, which is 5. So we don't change the z, just 5. So what we need to do is we convert the parametric equation of x and y into a Cartesian. Since we have the same t and the same t, it looks like we can use a direct trigonometric identity. So what can you do that? What can you do is x squared equal to 4 sine square t, and then square y, you have 4 cos square t. And then we know that when you total up them, x squared plus y squared, then you will get 4 of sine square t plus cos square t. So this is equal to 1. Then you will get 4. So you have a circle with radius 2, center at the origin. Okay, but don't forget, this is only for x and y, but you have z equal to 5, meaning that at z equal to 5, on the plane of z equal to 5, you can have the particle moving around a circle. Okay, it looks like you have something like, so this is your x, this is your y, and let's say this one is z equal to 5, then your graph is something like this. Okay, so that is 5 along z. Okay, so whether you move, this is you move that way or that way, so it depends on your tangent vector or unit tangent vector. So now it's time for us to sketch. Okay, because sometimes it's quite complicated for us to imagine on the 3D. So why not we just plot this, just to easy for us to imagine. So just sketch on 2D. So the sketching on 2D, you will see a circle, right? A circle with radius 2 on y-axis plane, which is this circle is actually this one, but this one, when you see, when you just your vision, when you are sitting or standing along the z, and you can see this line. Okay, so now for sketching of the position vector. So the position vector is 205. So where is 205? 20, so x2y0. So x2y0, you are here. Okay, and this one is always happen when z equal to 5, at z equal to 5. So 2, 0. So if this is 2, maybe this is your x here. So this is 2. So x2, y0. Where is it? Here, right? Over here. So that is, you are over there. That is your position when t equal to pi over 2. Okay, so that is your position. So now we have to label. Okay, the labeling is very important. So if you want to label on 2D, so how can you do that? So you have to draw a straight line from the origin and point to that point. So you can state that label. So this is the f when t is pi over 2. Okay, so meaning that in this case, how can you label that on 3D? So you start at the origin and you point to that. Okay. So this one is position vector. How can you sketch the position vector on 3D? So then you just tell us our label. This is the f at pi over 2. They are actually the same. But this is your vision from the above. Then you can see this. Okay, so it's just for explanation. But in exam, maybe you don't have time much. You don't have time to do both. So just for my explanation so that you clear with that. Okay, because this is 3D. So sometimes what I'm imagining is not the same that you can imagine in your head. So that's why I put here both. So easy for you to understand. Okay, so now where is the t? So now we want to plot the t. So as we know that the t is the it's just like a tangent. So tangent line. So you are over there, right? So the tangent should be that way, whether that way or that way. So this direction depends on the point that you have. So now this is on 2D. How about on 3D? So actually you are having something like that, right? Whether that way or that way. So now we want to see from the point, from the value that you obtain there. Okay, so now again, for plotting, you cannot use this direct value. You have to add with your position. Okay, this one you have to add. Okay, so 0 plus 2, 2 plus 0, 0 plus 1, and 5 plus 0. So your to plot, so here I put to plot the t at pi over 2. So it's become now your new point now should be 2 plus 0. So 2 plus 0, you got 2. And 0 plus 1, you got 1. And then 5 plus 0, you got 5. So 215. 215. So where is 21? 21. Let's say I'm explaining using 2D. 21. So this is 2. So this one is 1. So your point is here. So then how can you label the t? So please don't start from the origin. So it is completely wrong. You can see the tangent here, right? Because just now we expect that the graph should be like that. So that's why I'm saying if you start from the origin, so completely wrong. So you have to start from your position. Your position here is at 2, 0. So now you draw a line, put the arrow, and you know that your direction is anti-clockwise. Okay, so then you have to label. So I don't have enough space, so I just put the okay, this one. So this is your unit tangent when t equal to pi over 2. Okay, so that is sketching on 2D. Now where is the 3D? So what do you think? Our sketching is this way or that way? It should be this way, right? But then how can you uh, justify that. So it's basically from the point that you have. So 215. So now, as I mentioned before, it's hard for you to find the point on 3D. So x2, so look at here, 1. So 1. So that is the point, and you project that. You project that along the 5, so maybe around here. Okay, and you can see that now your line now become this way, that way. So that is your t. You have to label. So that is your unit tangent vector when t is equal to pi over 2. Okay, so you can see that your result match with your calculation, right? Okay, now we haven't complete yet. So unit normal. Okay, unit normal, look at the 2D. 2D minus 1, 0. Minus 1, 0. Okay, again, you cannot directly use the minus 1, 0 again because you are starting from the point of 2, 0, 205, meaning that to plot. So your unit normal vector now at t equal to pi over 2, you have to add. Okay, so 2 minus 1. How can we have negative minus? Because from your calculation, you obtain minus 1. So 2 plus negative 1. So you have 2 minus 1. 0 plus 0. So you got 0. And then 5 plus 0, you got 5. So you get 1, 0, 5. Okay, 1, 0. 1, 0. So this is the point. Okay, so now your labeling of the vector, the position vector and the end overlapping. It's okay because I understand this is 2D, right? So you can see that on 3D. So overlapping. So how can you plot that on here? You should be starting from 0 to 0. Your starting point here, your position now. So you draw a point, a line point to that direction. And this one is your unit normal at t equal to pi over 2. So that is the sketching on 2D, but you have to sketch in 3D because your graph is in 3D. Just my explanation to you, okay? So where is the point of 105? 105. Okay, x1, y0. So that is your point. Okay. So I didn't have any other color. Green. Okay, green. So 1, 0 is here, and then you project along the to 5. So maybe over here. So that is your point now, and then put the arrow, and the arrow should be not from origin down here, but starting from your position over here. So you draw a line. Which is point to that point, and that is your n. Normal unit normal, n at pi over 2. And you can see that they are actually perpendicular each other and point inside. As you can see here, the where is your t just now? So this is your t. So this is your t and this is your n. So they are perpendicular each other, and as I mentioned before, the property of the tangent vector or unit tangent vector is always tangent to the curve. Tangent to the curve, and the direction provided is actually tells you the direction of the particle the moving of the particle, the movement of the particle, sorry. And then the unit normal always point inside the curve. Okay, so hopefully you're clear with that. As I mentioned before, this is favorite question during the exam. Okay, so I think it's enough, but I think you can in the notes I give you some exercises there, so I hope that you can do. Okay, so from the exercise given, sketching the vector function, and then position vector, unit tangent vector on the same graph. So another one, the same thing, they are all about the sketching of the function, and also find out the tangent vector, sketch the graph. And this one, find the r at t equal to 0, r prime at t equals 0, and r double prime. Remember, r double prime has the same direction as n. Okay, r prime has the same direction as unit tangent. R double prime has the same direction as unit normal. Then you have to sketch the graph. Remember, for the r prime, unit tangent, tangent vector, unit normal, you have to start from your position. So kalau nak elakkan awak lupa, letaklah orang supaya this one can remind you that you have to start here, not the origin. Okay. Number 4, you are given a function. Okay, but here I'm not sure whether this is complicated or not, but you can try. Your z component, there is a function, but it's okay, you can try. Okay, so this will become your exercise, and maybe it's become your homework.